Hello there and welcome to another video tutorial on electronic configuration. In this video we are trying to determine the electronic configuration of your iodine anion or iodine ion with a negative charge as seen here. Okay, so that's a -1. It means, as what we have shown in the previous videos, when there is a charge it means that there is an added or a subtracted electron for electronic configuration. Now as you can see, there's a negative charge. It means there is an additional electron in the total number of your electrons. So let's locate your iodine ion on your periodic table. Alright, so as we try to see here, iodine is element number 53 and it belongs to group number 7. Alright, so from that information we will know that we are expecting 53 as your total number of electrons, and we have 7 valence electrons, but that is for the neutral iodine. Remember, we are trying to look for the iodine anion or the iodine negatively charged ion, so it means that we need to add one more electron. So instead of the 53 as a total number of electrons, we will have 54. Alright, so let's write it down. Alright, so according to the periodic table, iodine, neutral iodine is element number 53, so that it tells us that we are expecting 53 electrons for the total number of electrons. However, it has a -1 charge, so we need to add one more electron, so the total becomes 54. So we will be distributing 54 total electrons for the electronic configuration. So let's look at our guide for the different energy orbitals. Alright, so again, on this side, on your left, is your orbital diagrams with increasing energy levels. So 1s, 2s, 2p. Then here is the diagonal way of showing it in a illustration. Okay, again, n represents the number of shells, and then each box or each orbital can only accommodate 2 electrons. So total of 2 for the s orbital, a total of 6 for the p orbitals, a total of 10 for the d orbitals, and a total of 14 for the f orbitals. So we will now fill up the 54 total electrons for iodine ion, and I have filled the first or the lowest energy orbital, so that's 1s. That's 2 electrons, so that's 1s2. We go to the next, that is 2s1, 2s2. Then we have 2p1, 2, 3 again. Distribute first in your degenerate orbitals before pairing up. So that's now a total of 10 distributed electrons out of 54. So we only have how many more? 44 electrons left to distribute. So let's do that all together. Alright, so I have now filled all the total 54 electrons. So we started earlier with just 1s2, 2s2, p6, then we now have 3s2, 3p6, 4s2, 310, 4p6, then next 5s2, 4d, 10, and 5p6. Now originally, if that was a neutral iodine ion, it would only have 5p5, alright? But since it's a negatively charged iodine, it means it has an added 1 electron, so that makes it a total of 54, and that makes it 5p6. So let's write down our electronic configuration based on our filled orbitals. Alright, so I have now written our answer based on the filled energy orbitals that we did earlier. So that's 1s2, 2s2, 2p6 here, which is a little error on the writing, so let's see that. 1s2, 2s2, 2p6, and next 3s2, 3p6, 4s2. Alright, until here, then next 310, 4p6, 5s2, 310, 4s2, 310, 4p6, 5s2, then next we have 4d, 10, 5p6. 4d, 10, 5p6. Then if you count, okay, remember the electronic configuration, this here is your shell number of shells, then S represents your subshell, the shape of your subshell, SPDF, then the superscript here represents a total number of electrons in that orbital, so that's 2 for S, P, that's a total of 6, a maximum of 6, and D at a maximum of 10, alright? So if you count, that's 2, 4, then 6, 10, 12, 18, 20, 36, 38, 48, 54. So that is corresponding to our total electrons that we have accounted for earlier, which is 54. Now let's compare our answer to the Wikipedia page. And here is the Wikipedia page for neutral iodine. Okay, so that's 1s2, 2s2, p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10. Again, this is written in increasing number of shells. So first, second, third, fourth. Alright, so that's 1, 2, 3, 4. So the outermost shell is a fourth shell. However, no, sorry, we still have the fifth here. Sorry for that, I didn't see this. You have 5s2, 5p5. Alright, no, sorry. This is for the, yeah, this is still part of the configuration for iodine, sorry. That is a total of 53 here. And again, that is for the neutral. However, we had the negatively charged iodine, so we need to add one more, so that's becoming 5p6. So originally for the neutral iodine, that's krypton here, corresponding from 1s to 4s2, sorry, 4p6 rather. Krypton, then a 4d10, 5s2, 5p5 for the remaining electrons for iodine neutral atom. However, since again we are dealing with an iodine ion with a negative 1 charge, it means we have an additional 1, so that becomes 5p6. Now if you try to compare, that is actually the configuration of your xenon. Alright? So if you do write the core configuration for your iodine ion, it is actually your xenon. So that's close, open, close bracket xenon. That's the core configuration for your iodine ion. Alright, so it's actually of an equivalent electronic configuration. There's a special term for that, and that is known to be isoelectronic. Iso meaning the same, and electronic, of course, refers to the electronic configuration. So iodine ion and xenon are isoelectronic in nature. Alright, so that's all for this video. Thank you for listening and continue learning.